Good morning and welcome. I'm Courtney Power. I'm NextFlex's Learning Programs Portfolio Manager. And today I'm excited to welcome you into the world of flexible hybrid electronics and advanced manufacturing at NextFlex. As always with virtual meetings, we ask that you use your best Zoom etiquette, so please stay on mute until the end when we have question and answer. Feel free to use the raise hand or the reactions button if something specifically speaks to you. We love thumbs up and celebrations. So you may not know this, but Manufacturing Day is held on the first Friday of October every single year to kick off Manufacturing Month. And here at NextFlex, we are ready to celebrate. The fourth industrial revolution is rapidly changing the world around us, and new advanced manufacturing technologies means new careers, new skills, and new opportunities. And so today, to open our event, I'm excited to introduce you to Dr. Elizabeth Reynolds. Dr. Reynolds serves as a special assistant to the president for manufacturing and economic development at the National Economic Council in the White House. She is going to share with us the president's manufacturing agenda and set the stage for why manufacturing is a national priority. Dr. Reynolds?
Thank you, Courtney, and good morning, everyone. A little bit closer to afternoon here on the East Coast. It's a real pleasure to be with all of you on National Manufacturing Day, a chance for us to celebrate our manufacturing base and our skills and opportunities here in the country, and think about how we take all of that forward to create real opportunities for the 21st century and for a globally competitive United States. I'm going to talk a little bit about the administration's agenda in manufacturing and how you all fit into that agenda going forward. I want to say, first and foremost, I come from an old textile mill town in New Hampshire, Manchester, New Hampshire, which was one of the first places where we started making textiles in the United States. Today, it's one of the world-class leaders in robotics and biopharmaceuticals and all of these exciting areas where advanced manufacturing is taking place today. The Biden and Harris administration is focused on really rebuilding manufacturing capabilities in this country. I think all of you potentially have seen how over the time of COVID, we've had some real challenges with our supply chains. If you've been trying to get a new bike, if you've been trying to get your new smartphone, if you've been trying to get a few other things, you'll see that there have been long delays in getting them, in part because we don't make them in this country anymore. But the administration is very focused on moving to a new agenda, which is really about inventing it here and making it here. And that's part of what NextFlex agenda is. So we are actively looking for ways to build our capabilities and innovate, as we're doing here at NextFlex, as you all are learning through robotics and 3D printing. We're going to be looking ways to commercialize those inventions. So take them from the lab, from the Manufacturing USA Institute's facilities, and take them into the marketplace and grow them here so they have great jobs for all of you and bring lots of benefits to the country. Another key piece of our agenda is around skills. All of you are learning incredibly important skills that will be the foundation of our manufacturing going forward. This involves the theory that might come with manufacturing, but also the practice, getting our hands around how we actually make things and how we can use those skills to create a really bright future for everyone. The administration is very excited about the next generation and making sure all of you are leaders in our manufacturing future. This is a future that involves everyone from across the country in all corners and all communities. We're very excited also to be using our technology to make sustainable manufacturing and to fight climate change. This administration is very focused on ways in which manufacturing can help us with sustainable methods, materials, technologies. They're going to create a cleaner environment and also help us be globally competitive in the 21st century. So with that, I will hand off and say thank you very much for having me here. Please come visit at the White House if you ever coming east, and look forward to a great day today. Thank you.
Thank you so much, Dr. Reynolds. So now I'd like to introduce Dr. Malcolm Thompson. He is our CEO and Executive Director here at NextFlex. He has a special message to welcome you to Manufacturing Day.
Hello, I'm Dr. Malcolm Thompson, the Executive Director at NextFlex. and I welcome all the students and teachers here today to Manufacturing Day 2021. So NextFlex is a manufacturing innovation institute focused on revolutionary electronics through flexible hybrid electronics. And we're pleased to be celebrating modern manufacturing in the USA. It's all high tech, very challenging, quite fascinating, and there's a place for you here as you consider your further education and career plans. So following the short video presentation, you have a chance to visit the break room to speak directly with NextFlex engineers about education and career opportunities. So be thinking of your questions as we proceed. You can ask them anything. Now, I'd like to introduce Tracy Frost, Director of the Manufacturing Technology Program at the Office of the Secretary of Defense, who will talk about why growing the manufacturing base in the US is so exciting and important. Thank you all again for joining us today. Welcome, Tracy.
Hi, everyone. I'm so glad that I can join you today to celebrate Manufacturing Day. Have you ever thought about how things are made? If you look around your house or your school, all of the items that you see and use are made by someone. Even look at the clothes that you're wearing and the shoes on your feet. Did you ever think about how they're actually made? Now, what if your shirt or your shoes could do something that a cell phone does? How would you make the material of your shirt smart enough to hear and see? How about storing information? What about materials that help regulate your temperature? What if you're too hot or too cold? Not a problem. Your shirt could cool you off or warm you up. Maybe it will change colors based on the temperature outside, or you can match your background and blend in. All of these things can be made possible with advanced manufacturing. My name is Tracy Frost, and I work for the Department of Defense. And every single day in my job, I get to work with teams of people to do just this. We're using advanced manufacturing to come up with new ways to make products that you use every single day even better, and to make products that we don't even know exist yet. We're helping people take their crazy ideas and inventions and finding ways that these inventions can actually be made so that you and I can go to the store and buy them. But let's think about this. What if someone can't just go to a store and pick something up that they need? Say like our deployed military troops or even astronauts. We're developing ways to allow people to make what they need from wherever they are. Like if they're already in space or on the moon. We can send them a design from anywhere in the world and they can make it themselves. I grew up in Florida, and once in a while when I was a kid, I would go to work with my dad and see how boats were built. That sparked my curiosity into how everything around me was made. I then went to school for engineering and had the opportunity to build and then race a small human-powered submarine. In that opportunity, I researched many different manufacturing techniques and learned even more ways to build things. Now, like I said, I get to work with amazing people now, like the people at NextFlex. They're advancing manufacturing so that they can take any idea for a new product and help someone figure out how to actually make it. Some of the things that NextFlex is specifically doing with advanced manufacturing is transforming rigid electronics into stretchy electronics. They're turning Band-Aids into something that can deliver medicine or help you heal faster from a sports injury. You may have seen the new foldable phones, but what if advanced manufacturing technologies that NextFlex is working on can make that phone even smaller? Imagine your phone being just as thin as a piece of plastic that you can roll up or bend. They're also helping out the environment by creating sensors that monitor soil and water streams from factories to help reduce pollution. So I hope that you have a great time today celebrating Manufacturing Day, and be sure to tell your friends and family everything that you learn about manufacturing today. You could be one step closer to turning a crazy idea into something that we use every day.
All right, Miss Frost is right. Manufacturing is in the business of, as we might say, all the things we use every day. But as she said, manufacturing is also in the business of things you've never heard of or thought of before. To show you one of those things, I'm now excited to offer you a sneak peek into the manufacturing life cycle, from idea all the way through prototype. You'll see some of our engineers attending class and working through what could be an impossible problem. So let's see how they do. Do you think they'll pass?
Okay. Hello, everybody.
Professor Wall, you're muted.
Every time.
How about now? Okay, great. Is everybody here? Is Eddie here?
Yeah, I'm here. I'm here.
Oh, okay. Well, welcome back, everybody. Today is your final challenge for this class. I hope you'll take this very seriously because remember, this is a big part of your grade. The challenge you have today is to come up with a way to develop a method for measuring things. And you're going to measure things like how to look to see if, say, a bridge or a dam is becoming damaged or about to fail. Maybe it's measuring something in agriculture or even on the human body. Now, the trick in this, and this is how I always get them, but the trick is it has to be something that can be manufactured quickly so you can get prototypes out today. And the process you use should be environmentally friendly. Any questions?
Can't we just use a camera?
How about like we use really small sensors?
But we attach ICs to everything.
Well, like I built an Arduino in high school, so like maybe we can use that.
I don't know. I just don't see you guys are getting it.
Professor
It's-
Wall, I got a truck.
What?
I can drive over the bridge.
Try again, Brett. It all sounds like you guys are going to have a real challenge today. Good luck. You're going to need it.
How are we supposed to do this? I mean, we're supposed to monitor some bridges, people, and trees all together. Like,
Oh, wait, I actually have been playing around with these sensors. Maybe that could help out a
okay,
little
so we
bit.
got sensors.
Oh my God, now what?
You know, we need to, have it today. You know, we can't just like design it from scratch.
Let's use an Arduino. They're great for fast prototyping.
Okay. And what about environmentally friendly? I mean, these things aren't great.
What about paper?
Paper works.
Paper.
I like paper. But how do we
He's gone.
how do we put this together though? I mean, and how do we put it together? Well, what's this?
Oh, this is the design. I have an idea.
Okay, so what's your big idea?
I'm thinking maybe we can print it on our circuit on a piece of paper.
Well, how? I mean, this is not conductive or anything. How do we make a circuit board out of that?
I got this special pen. Yeah. You can draw circuits with it.
Do you really want to, make this by hand, by drawing it?
Okay, the pen is not going to work. I have an idea.
So we have the printing covered. We have 2 conductive layers on a thin, environmentally friendly plastic substrate. But how are we going to get all these components on here? Look at all this.
Oh, I mean, they're all in here. We just need to put them on there, right? It's just like, you just got to put them there, put one there. It's going to work.
That's a bad idea.
Oh.
Let's go back into the fab again. We did it!
Yeah!
Whoa, this is like totally flexible.
Yeah.
Flex it.
Flex it.
Flex it.
Well, more importantly, it actually fills the requirements for pressure wall. You know, it monitors something, it's environmentally friendly, and we got it done today somehow.
And it's cheap.
Let's go show him.
Professor Wall, look at what we made. You think this is going to give us all A's?
What is this?
Well,
First, we printed with conductive ink.
And then we placed off-the-shelf components on it.
That's flexible, like paper. And it's hybrid. It's electronics.
yeah. What are you going to call it? I don't know.
FAG.
Well, that's pretty cool. Actually, is this ferrosilicon dye on here?
Yeah, it is.
Wow, I've never seen that before. Okay, this is really cool. I'm very impressed, but okay. It's still a bare circuit. What are you going to do if you have to package this thing?
Well, I think we have something for you there. Have a nice summer, Dr. Wall.
Oh, man. I don't know. I still don't get it. I can't figure out how they did this. It's amazing. No class has ever been able to solve this problem. This is really amazing. Oh, well, I guess they all get A's.
All right, so I hope you all enjoyed that insider's look into the manufacturing process and the amazing things that we can make with flexible hybrid electronics. But now it's your turn. We have some of the stars of our show, otherwise known as our engineers, joining us today who are ready to answer your questions. Do you want to know how they got to where they are today? The coolest project they've ever worked on? The floor is yours. Feel free to drop your questions in the chat or use the raise hand feature and come off mute. So we are going to open the floor for the next little bit. And I would suggest for those who are joining us, if you go ahead and set your screen to speaker view, which is the view button on the upper right-hand corner of your Zoom screen, that will allow you to see exactly who the speaker is. So you'll be able to find the engineer that is talking at the time. So I'm going to go ahead and check the chat and see if we have any questions yet. I don't see any yet, so I'm going to go ahead and tee up the discussion, and then you guys feel free to jump in on the chat. So for any of our engineers who are ready to answer, okay, we have one. So how many tests on average do you need to conduct before you find your prototype? So
Let's
anyone? Yep.
Guess
Go
I
ahead,
could
Rob.
answer that. But so I guess before you test before you find your prototype, I suppose the question. So I'm an engineering manager of the software test team, so I felt like I should chime in. I imagine what we're getting to is kind of feasibility work, right? So you're trying to go through this iterative process, which is part of the almost artistic aspect of any kind of engineering design, where you're trying something, you fine tune it, you try it. So it kind of depends on the amount of risk. So the more we don't know something, the more we have to kind of go through a lot of iteration cycles. Something that we've done before, you reduce the iteration cycles. So it kind of really depends. I don't think there's a really good number, but maybe 4 iteration cycles, 5, depending on a prototype.
All right, so our next question is, can something really be prototyped in a day? I thought real things took years.
I've seen it in a day. I think all of us have experience on some level with a 3D printer. And so what we're doing is not too dissimilar, but for circuits. And so we have really fantastic engineers that can take a design, and we have fantastic people on site and a whole fab on site. So it does allow us to do some really creative things very quickly.
Could you touch on some of the specifics of kind of the equipment that you have and what they do? I know we got to see some that are applying the sensors or printing the circuits. And would a student or a class ever have access to something like that?
Yeah, so I think again the analogy to a 3D printer is something that's a very digital tool that we use is the end script. And it's you can think of it as a roboticized arm with a dispense head. And we've been able to use that to create circuits almost on the fly, just very quick turnaround, just like a 3D printer. There is kind of a emerging commoditization of some of these ideas. So Volterra is sort of a desktop unit I can see in a classroom. It's more expensive than a 3D printer, but we actually use it as a quick tool, not as precise, but you can definitely get a lot of the fundamentals both on rigid and flex with a conductive silver.
Okay, so what is the most unnecessary thing you have ever designed? And if any of our other engineer fab participants want to answer that question.
I think that's kind of hard to say. So unnecessary, I think, sorry, I keep answering, but I think, a lot of what we do is trying to meet a human need. I suppose the most unnecessary is more of a technology demonstrator that we've used to just show kind of techniques with thin die. And for the most part, it just, blinks some LEDs, I suppose, but it was more of a demonstration of different manufacturing processes.
Okay, and then we have, do you offer internships? And then I'm going to actually add on, and what internships or clubs or extracurricular activities did you participate in that you found most useful as you entered the workforce?
Yeah, we do offer internships actually, and we have some in several areas. So we have software internships. We have opportunities for working in the fab on some of the equipment. You can work on print and assembly, really every aspect, and contracting, any really area that you're interested in. Help get you started.
Yeah, and
awesome. Thank you, Nathan.
To follow on that, a lot of our interns had a lot of experiences with robotics clubs that I thought was really useful. Any kind of Arduino, I think that gets you some familiarity with embedded systems, which is a lot of what wearables are. And any kind of engineering camps to build something, projects, that's a lot of stuff that our interns come in with.
In fact, quite a few of our current staff engineers joined in from a position of being an intern, and we're very proud of that. They came from all walks of life. Yeah, like Xander is one of them. I'm not sure Xander is you are on video now, but he came in from a very unique background, from being a designer. Designer in the sense that designing for the look and the human factors, not the electronics itself. And we found that extremely useful.
So our next question is, for a high school student, do I have to go to college to work there? So if anyone can answer specifically for NextFlex, and then I think generally to the manufacturing technician and technologist roles.
I mean, personally, I we take interns that don't have, that are actually in high school, right? And we see a lot of potential. In manufacturing, there's a lot of need for trade. And at least in my prior lives, I've seen people go pretty far without a degree. I will say that there's a certain point where I think it makes sense to get a degree to kind of get a higher level view and to kind of go from being someone that just regurgitates to someone that creates, right? So if you're interested in creating new processes, new techniques, new methods, I think it does help to go for that degree.
And I will just add on to that, for many, a four-year degree is not necessary. Many technicians and technologists and through the trades, as Rob mentioned, can pursue certification through the community college system. within your local area. There's a lot of great mechatronics and advanced manufacturing pathways available through your local community college system. And it's a great way to very quickly get the skills you need to be employable in the advanced manufacturer sector. So I'm going to combine a couple of the questions from the chat. So what does your company do? What does NextFlex do? Who are your primary clients? And is there any project that you're working on right now that will blow our minds?
So I guess I can jump in there for one on the, in terms of what NextFlex does. I think as our speakers earlier mentioned, a lot of what we're trying to do is to reinvigorate manufacturing in the United States, particularly in the area of flexible hybrid electronics. And so that means that we take, workforce development aspects, but also we are actively building and prototyping things on our own fab. So in terms of some of the things that I think are really exciting that we are doing recently and we can actually talk about, one of the ones I have been working on is a wearable confined space monitoring system. So basically for people that have the job of crawling into aircraft fuel tanks, it will detect when there are hazardous gases in their vicinity instead of, just basically waving a sensor at the entrance.
Yeah, if I could, I'll add on to that. Rob was talking about some of these things that make circuits, and they're literally like, a pen, like was described in the video, but it's all robotically controlled, so it can draw things. We're working with NASA right now to develop a human monitoring system that will be used in space. And we're doing it so that they can actually have that printer in space. And when they need to apply a new patch to an astronaut, they can just go push the button and it will print it for them. Pretty cool.
That's great. So someone did ask if there's any internships on the East Coast or if we're exclusively in California. So NextFlex itself is a manufacturing innovation institute, and our only location is in San Jose, California. So that is a true statement. But I would encourage you all to check out Manufacturing USA online, and there are manufacturing innovation institutes across the country who may have other opportunities that we at NextFlex can't speak on their behalf, but advanced manufacturing, like Dr. Reynolds said, exists across the country in many communities and locations. So we did get a question really on the substrate part of what was shown in the video. Can you really make electronics out of paper, or was that a joke?
So I'll jump on that one. And the answer is, in short, yes. There's a few manufacturers who are actually moving to print on paper. A lot of this is for things which are more disposable. So basically the idea being that if you're printing a metal on paper, if it does go into a landfill, it will eventually degrade down into, and disappear into the environment. Whereas if you are printing on something like plastic, it is a little bit harder for it to be recycled or discarded. So yes, you can do that. And generally for the clean room aspects of it, you don't really require very much. A lot of your traditional electronics manufacturing is just a regular shop environment. You don't really need a full clean room for that.
Thank you for answering that. So open questions specifically to any of our engineers who maybe haven't chimed in. What do you think the most important non-technical skill is in your day-to-day existence? So not just being able to design circuits or work with the machines. What do you think helps you succeed in life and work? Dr. Wall?
Thanks. That's a great question. And I would say that probably one of the number one things is curiosity. If you really want to, as Tracy Frost talked about, really want to understand things and you want to understand how things are made or how things work, that's number one in my book.
All right. Anyone else? Xander?
Yeah, so well, I do come from a long, not long, but some technical background, obviously. But I think there's definitely a creative side to a lot of what I do. And that's probably the biggest thing I bring in. So exercising those sort of skills, can't hurt. As you can imagine, in a sea of engineers, it is a nice thing to bring to the front.
Yeah, one thing I would throw out there as well is being, I would say, courageous in the face of challenges. Not everything is going to work, but you can learn from those failures and progress. So you'll never get anywhere if you just are afraid of failing. And it's very important to just get out there and try.
That's great. I will also add from my experience on the workforce team and working in an advanced manufacturing company that teamwork and the ability to communicate. So a lot of times we have great ideas in our head, but we need to be able to get them out onto paper and then work together as a team to really figure that out. So I think that that's what our video really showed well, was that it does take an entire team and lots of different ideas to come to solutions. So how does our company distinguish itself from competitors, and do we collaborate with other companies on projects?
Could I say something about that?
Yeah, absolutely.
So we're a consortium, so we have 100 members, companies primarily, government organizations, but that means our thesis is collaboration. We all work together on projects on different things. And by the way, those companies are spread across the United States, and they all take, generally, they all take students as interns. In addition to that, the community colleges we work with are spread across the United States. And there are programs like the Earn and Learn program where students go to college for half of the week and then go and work at a company for the other half, on which they get paid. So that all helps. So there's also lots of creative ways of getting involved, no matter where you are geographically or whatever your situation is. We try to make that easy for you. And I think that's really important. And collaboration is key to everything we do. We often just don't do the project on our own. We do it with another company which has another expertise. Complementary things, bringing them together, where in the end, the whole is greater than the sum of the parts.
Yes, synergy is what advanced manufacturing is all about, is creating greater goods from the bits and pieces. So this is specific to discussing FAT. So you mentioned that a phone could be rolled up, but the screen would still be glass, so wouldn't it break? Does anyone want to jump in on kind of what an FAT substrate can do?
So
Janos?
we don't actually build the displays, but there are companies who develop displays and related devices on flexible substrates like plastics. So that is emerging. And what we do is kind of connect and integrate these various technologies. I mean, you already see flexible displays emerging in a commercial world. Our goal is make it possible to have all the adjacent technologies that's required. The display has to be driven by electronics, so you need the microchips. And what we're doing is making those chips themselves flexible as well. So the electronic system need to band together with those displays, with anything that we have in mind. And what's really interesting about it is what makes it possible is we bring together technologies that are normally not present in electronics manufacturing. And that means we need to understand what's available in other sciences and other topics like textile manufacturing, like robotics, new materials. And so that's kind of expanding the boundaries of what conventional electronics is. And that's why we attract and work with all kind of partners from different industries who not normally present in electronics manufacturing. That's why we also hire people from all walks of life.
Courtney, if I can jump in as well, just to add a couple of thoughts there.
Yeah, definitely.
Some notes in the chat about other materials, and they're absolutely right. So there are displays that are built on plastic, for example, to make them more robust. You can imagine other types of systems that are built on plastic for exactly that reason. So imagine an X-ray detector that might need to go out into the field with an EMT to be able to take an X-ray, find out if you can safely move somebody with an injury. So those kind of technologies are in development also. But even beyond just using plastics that may be more robust, less brittle, less likely to break, and maybe have the ability to bend, we're also working on projects based on stretchable substrates. So imagine something like a rubber band or a large stretchable sheet of rubbery material that you can put your electronics onto and not just bend it, but actually stretch it around another object. That really begins to build in some of the robustness that people are thinking about in the chat.
Thank you so much, Scott. So what smart manufacturing practices does your company implement?
Well, from my point of view, I think the smart aspect is the combination of robotics, software, and some of the work that Nathan's doing is actually to start incorporating AI-based or neural network inferences to some of our image processing. So to me, that's the next stage of manufacturing is what can you do once you highly digitize the manufacturing process. And that's what we do in our fab.
So it's the automation of the design process or aiding the design process with design tools. And we work with the companies engaged in that. But it turns out we need new solutions to this because we work with new materials, new substrates, new arrangement of the devices. Then, as Robert says, also an automated way of driving the manufacturing process and perhaps aiding that with AI. Then the inspection, right? And then also reliability and all of those aspects that down the line will ensure that the device will work for a long time.
Awesome. Thank you, Janos. So our closing question for today is going to be a two-parter, and I would invite any of our advanced manufacturing professionals, whether you are actively with NextFlex or participating from another location, to feel free to come off mute and chime in. But can you give a quick story on how you got to where you are today, and what piece of advice would you give to an aspiring student looking into a career in STEM or advanced manufacturing?
So I had a very roundabout career, which Janos hinted to. So I started in industrial design, and then I went into something akin more to Hollywood special effects. And then I went back to a community college for more relevant CAD and manufacturing techniques. So a lot of weird backgrounds rolled into one. So that's kind of what I did. I wouldn't necessarily give that as the ideal pathway, but my advice would be to diversify if you can. So, do your regular college major, et cetera, and definitely have a minor, if you will, on the side. That's kind of what I did in college.
And hobbies can be ways to accelerate your learning in your minor, whether you're really interested in robotics or just power drones, whatever you do on the weekend. Really, hobbies can be a great way to demonstrate additional learning and to practice those skills before you get into a lab. So any other engineers want to chime in? How did you get where you are, and what piece of advice would you give?
From my point of view, oh, go ahead.
Go ahead, Rob.
Okay. But well, then I'll go first. From my point of view, I'd say, really follow your passion. So I've always been interested in technology in a lot of ways. I think it's just modern magic, right? And I studied electrical engineering because I was interested in it. I got a minor in computer science because I was interested in it. I started working on drones, real drones, because I was interested in that, and traveling. And so I combined those two in my first job. And then I was also interested in health. And so I've done that as well from a diagnostics point of view, and found a lot of great pleasure in helping those in need. And I found a lot of passionate people working on that. And then with NextFlex, what I love is combining those things. We work on so many different projects, both medical, DoD, drone related. and it's such a creative space that it really makes a lot of fun. So again, in my opinion, I think following your passions, and then success will come.
Thanks, Rob. Alexander?
Sure. So I think in a nutshell, what I would say is to, much like Rob was saying, you kind of want to follow your passions and do something that you enjoy. Personally, I went through I would say, a slightly more traditional path in terms of going through a 4-year degree in physics, and then I got my doctorate in physics. But then I sort of pivoted a little bit in terms of going to AFRL for a few years and learning a little bit more on the manufacturing side before jumping into NextFlex, which, if anyone knows physics, you know that there's a little bit of a jump between application and engineering and the more academic side of things. But I think the moral of the story is do what you love and don't expect that your degree is going to define you. What you do and what you love will be what defines you going forward.
Thank you, Alexander. Any other professionals on the call want to share their path? Nathan, Janos, Dr. Wall.
I can go. I guess my career path was a little unconventional as well. I switched majors a few times in college and eventually landed in printing and packaging. So I did commercial printing for my undergrad, and then packaging with an emphasis in materials for my master's. And that was a really unique way of coming into the field because you get to see the process first. And you get to work with these, huge machines and see some really interesting stuff, a lot of everyday things, and see how they're a lot of everyday things, how they're made. And then we go into NextFlex and you're sort of adapting those processes to make things that are completely new. And now I do some software work. So a little bit in a lot of different areas.
And do you have any advice you would give to an aspiring student?
I think definitely curiosity, and also just learning I think curiosity combined with, working on a team with other people and really collaborating with other people. When you have other people, they give you energy and they give you, insight that you don't have. And it really, it keeps you interested, but it also accelerates your growth too.
Awesome. Well, we have a number of classes that have joined us today, and so we want to be respectful of your bell schedules and maybe get you out a little bit early so that your teacher can wrap up your day. So I'm going to wrap up today's event by saying thank you to everyone who came. We really appreciate it. If you want to drop in the chat where you're joining us from, that would help us be able to know kind of the span of reach of this event today. But I want to encourage you all to continue celebrating manufacturing during the month of October and really all year round. So I hope you all have a great day, and remember, flexible is in our DNA. So thank you for joining us, and please feel free to check out Manufacturing USA and nextflex.us to learn more about advanced manufacturing and flexible hybrid electronics.